So let's see if I'm actually able to do this. It said that I recorded last time, but I couldn't figure out how, and it said on the system that it saved it, but maybe it failed. So I'm not sure if I uploaded it correctly. I saved it a second way, so we'll find out how my recording is going. My goal is, of course, to be able to record the lecture for all these classes and put them in the YouTube channel and post them to the internet, because that would be a good thing, and it would help us in our effort to be able to fully use the internet to see stuff. Now, is it still too bright here? Looks a little bright. I don't want to turn all the lights out, but I want people to at least be able to see what's on the board. Is that better? I think that's better. So, okay, so we left off with this case study on the CSI effect of this guy who was living up in southeastern Ohio named Jermaine McKinney, and he had made an attempt when he committed this. Was initially a robbery and then it turned into a murder, and he had removed a lot of the evidence because he was a fan of CSI. So he'd removed cigarette butts, he'd removed anything he thought had his DNA, and he left footprints, but he thought he'd get rid of his boots. And then the boots wound up out on that ice in the frozen lake, and then he had the misfortune to have the news reporters reporting that the lake was frozen, as news reporters will do, and noticing that the boots were out there. And so actually it's kind of powerful if you have footwear. As a general rule, your DNA can wind up in your footwear. It's not everybody's favorite thing to extract DNA from, because footwear is kind of stinky. But in fact, and people generally speaking don't share their shoes. They might share a pair of sandals or flip-flops to go out to the garden with, but as a general rule, people don't share the shoes that they wear all the time, every day. So shoes tend to be a place you can identify somebody. So, and they match the foot, they match the heel print and everything to it. So he was convicted of 2 counts of murder and sentenced to life in prison. And his accomplices who were driving the getaway car and were helping him disguise the murder victims afterwards, because he basically tried to burn the murder victims to disguise what had happened. And that's a very common thing that people try to do, where they think, well, I'll just burn down the house and nobody will figure out what happened. They can actually pretty frequently figure out what happened if you burn down the house. So the family members also sued the perpetrators for wrongful death, and wanted to make sure that they could get to the bottom of what had happened, because they weren't convinced that the accomplices weren't more involved in the case, I think. So researchers have also been looking at this CSI effect to see, how big a problem is it really? So they interviewed a bunch of jurors. So they did research on over 2,000 jurors to find out what they actually watched on TV and how much they knew about the criminal justice system. And then they could figure out how much the actual jury pools had expectations for the CSI effect. And many jurors did expect to see evidence like DNA and fingerprints when they came to a major crime. But they didn't need to be CSI watchers to want forensic evidence. They wanted forensic evidence because it's in the news. So, and the more sophisticated the juror is, the more the jury expects good evidence. So as a result, the people who are picking the jury on the defense sometimes want to select out very well-educated people from being on the jury. So they might try and determine how much knowledge you have of forensics. So if you ever go on to become an attorney, or if you ever go on to become an officer a law enforcement officer, there's a good likelihood people aren't going to pick you to be on a jury. And if you're very well educated, get a PhD or an MD, advanced degrees, they tend not to put those people on the jury because those, come on.
Oh, yeah.
224?
Yes.
Well, talk to me after class.
Oh, that's what I was going to ask.
Oh, okay. Oh, are you asking about the writing intensive stuff?
Right.
I checked, and we should be able to be writing intensive officially.
Is this the only time that you teach this?
Yes.
Okay.
But
Well, that's a problem. Software engineering class all at the same time, so you can't take this.
well,
So I got to stay in there, I guess.
maybe. Talk to me afterwards.
Okay. 2:15?
2:15. I'll be up in my office.
Where's your office?
On the other side of the building, on the second floor,
Okay.
under Murray. Just ring the little phone and ring in. He's trying to be in the writing intensive section, and this should be the writing intensive section, and the other class we have is the non-writing intensive section. So we're getting the paperwork settled, so if by Friday I turn in all my paperwork, we'll be writing intensive. So that'll be good. So in other words, the more sophisticated you were, the more well-educated you were, the less they wanted you in the defense. So if you're the prosecution, you might want a more sophisticated juror, or you might not. Maybe your case isn't that strong. So you might not want a more sophisticated juror. So the more you know, the less likely you are to be on a jury, unfortunately. But you still may wind up on one. So we've talked a little bit in the lab on Tuesday. We talked about the Sherlock Holmes effect, and when you come to the Thursday lab, we'll have about 30 or 35 minutes of video on how Sherlock Holmes predated a lot of forensics evidence. But there's other aspects of forensics that historically have come along over the years where people have used observations and physical evidence to try and identify who committed a crime. So some of the first evidence that was used was in China, which had a very sophisticated legal system early on with government officials. And so they began to use things like fingerprints for identification, sometimes even using them as seals on documents. But the limited knowledge of anatomy, pathology, other aspects limited the use of forensic science. And so as a general rule, forensics was the exception and not the norm until the early 20th century. So they began to do things in the late 17th and early 18th century in terms of dissections and anatomy, breakthroughs in chemistry, and they began to use photography. That was actually probably one of the biggest forensic science tools that came along, was making a record of the crime scene and taking accurate records. And they began applying scientific tests to criminal trials. And by the late 1800s, there was almost all scientific fields had some aspects that could be applied to the study of crime, but it wasn't routine. So one of the things in the, we'll talk about this when we talk about biometrics and fingerprints, but one of the things that was a challenge for early forensic scientists was just figuring out who somebody is. So you arrest some guy who's doing something, and they give you a name, and it's a fake name. And they have a criminal record, but you can't get access to their criminal record or figure out if somebody's on a wanted poster, you don't know what other name they go by. So one of the early things people wanted to do was come up with a system of identification so they could figure out you were you. So a French scientist who studied physical anthropology named Bertillon, he came up with a system based a little bit on skull measurements and facial measurements and body measurements. So as if to the ratios of the different, there were specific measuring points on your skull and so forth that could figure out exactly what your dimensions were. And some of that was based on the idea that certain dimensions, certain kinds of people were more prone to commit crime. So there was a lot of prejudice against people of Slavic origin and Italian origin, and they were more likely to be criminals. because they were the immigrant population that were coming to the country. And so a lot of these programs were somewhat biased against people. But it was considered the most accurate system that they had. And if you go back in early forensics records, you find lots of people, where they started doing that mugshot. So they do the mugshot like this, and they do the mugshot like that. That came from the Bertillon system, the idea that they would identify you with the mugshots. And so they would take all these measurements, and they would enter them into the data along with your mugshots. And then after World War I, after the terrible carnage of World War I, it was so hard to identify soldiers who'd been lost in the war, they began using fingerprints as an identification system for the war dead. So they started keeping records of fingerprints and documenting that they were fairly unique. So fingerprints then became more of a method for human identification as well. And there were isolated instances where people used fingerprints to solve crimes earlier, but they became something that when you went into the military, you got fingerprinted. So we had a huge database of people in the military who had fingerprints. And so that was used then as part of the basis for solving crimes. So this is sort of a little timeline for some of the tests that they had. One of the things when we get to talking about toxicology in the class is that you'll find that in the 1800s and early 1900s, poisoning was a lot more common than it is now. People generally are not poisoning each other as much as they used to do. And I think some of it was because there were so many pesticides, there were so many rat poisons, there were so many toxic chemicals that people had access to, that it was fairly easy to get enough poison to kill somebody in one dose, or slowly add a dose of poison to people until they finally died. So one of the poisons, of course, was arsenic poisoning, and they came up with tests for arsenic, and forensic toxicology was one of the earlier forensic fields, trying to figure out who'd been poisoned. When folks invented the polarizing microscope, that was a big breakthrough, because now you could take crystals or materials and look at them under polarizing light and look at trace evidence and match it up. And a lot of it was also used for identification of poisons. In the 1800s, people began to use microscopes to detect sperm, and they began introducing this kind of poisoning toxicological evidence into court. They started doing tests for hemoglobin that were microcrystalline tests that were looked at under the microscope. And some of the first tests for the presence of blood were done in the 1860s. So when we watched the Sherlock Holmes video, one of the things he was trying to do was figure out a more sensitive test for blood. So the Bertillon system is like 1899, and by 1892 they started being very systematic in how they classified fingerprints. But it really became popular during World War I. Now I will tell you, I'm not very likely to ask you any of these dates on an exam. I'm just bringing it up because I like history, and it's helpful to know that this science that we're studying actually has a fairly short history in terms of its applications. So Sherlock Holmes then is somebody that is a fictional detective, but he's based on a physician that Sir Arthur Conan Doyle studied with, who was, I think his name was Bell, and he was famous for his deductive reasoning. And a good physician is very deductive. They come and look at you, and sometimes a really good diagnostician will look at you and be able to tell all kinds of things about you just by observing you as you come in and see them in the office. So they'll maybe know things about your occupation, know things about how you're responding, just because they're good at doing this. So he saw himself as the model for Watson, and he made up this guy Holmes. And so he was using Holmes to promote the idea that we could use forensics to solve crimes. So his sophisticated detective Sherlock Holmes was doing all these things long before people were really routinely using these things in solving crimes. So some of the advances of the 20th century are figuring out how blood types worked. And in fact, the Nobel Prize was awarded for people figuring out how blood typing worked. And they began working extensively on question documents. Locard, who we'll talk about a lot, that mostly I don't have people remember names of historic figures, but Bertillon and Locard are kind of exceptions because they were part of major systems. And Locard was really one of the first people to get funding for a real forensic science lab that was part of a police department. And he was his law is still used a lot in forensics, that anytime somebody comes in contact with a crime scene, they're either transferring evidence from themselves or evidence from the crime scene is transferring to them. So every touch leaves a trace. Either the trace is being left on you as you leave the crime scene, or you're leaving that trace behind at the crime scene. So that Locard's principle, that is something you should remember. So it took a while from whenever people discover something, it takes a while to apply it to criminal investigation. And as we got better and better at chemical testing, we got better at all these tests, which were very powerful at figuring out toxicology, very powerful at figuring out drug and alcohol testing. Interestingly, when the first DNA tests were developed, they very quickly had applications to forensics. The first applications were for solving cases of immigration. And so from the very beginning, as soon as people had quick ways to analyze human genetic variation, they started using them in forensics. And to this day, DNA forensics is probably one of the most scientifically robust systems of forensic evidence. And it was first used to solve a crime, though, a couple of years later. It was used in civil cases for immigration. So, as I said before, Locard's exchange principle is that when two objects come in contact with each other, the materials are exchanged. And it can be used to link a suspect to a crime scene. So this is a fundamental idea of crime scene investigation that is critical. So John Sammons, who teaches in our program, was telling me a story of a case where they were investigating a particular crime scene and somebody had broken into a building and had gotten motor oil on their shoes. And they could see a trail of footprints going away from the scene of the crime with motor oil on the shoes. And then they had a APB out for look around, and when somebody picked up somebody suspicious in the neighborhood, it was like 2 o'clock in the morning, so guys in the neighborhood were being asked, they looked at his shoes and it had oil. So that on the simplest basis, if you find the oil from the crime scene on the guy's shoes, it's usually pretty easy to link them to the crime scene. Microscopy made it a lot more easy to look at trace evidence, and microscopy also made it possible to do firearms examinations. And starting in the 20th century, we've had a lot of a revolution in computer technology. So computers, unfortunately, are being used to commit more crimes, and people are also using computers to steal identity. They're using, the whole Target mess, where people are stealing your personal information and your credit card number. Was anybody here affected by that? Did you have to cancel your credit cards and redo it? They're saying that you may also be prone to getting more spam now, that they may have sold your email address and personal identification. And supposedly Target is offering people who shopped between Black Friday and about the 2nd or 3rd week of December a free credit check. So you might want to sign up for that if you were shopping at Target in those vulnerable times, just to be sure that you're on the safe side. Sort of public service announcement. Make Target pay for that. I actually don't always shop at Target, but during that time I went in and bought 2 gift cards, so there you go. So now I'm in the vulnerable population too. So in the history of the crime laboratory, I mentioned Locard is famous not just for his principle, but for starting the first crime laboratories. And some of the first crime laboratories in the United States tended to be toxicology laboratories. And there's a popular book on forensic science that some of you might have read called The Poisoner's Handbook. Anybody read that book? They're actually making a Nova, you've read it, great. There's a Nova episode coming out on it, and I've pre-ordered the video. So when it comes, we should be able to see parts of the episode to see if it's good. And but there was early forensics was really tied into toxicology in the United States, and then eventually into fingerprinting. So those would be a couple of the really big programs. And as I said, there was some communities really embraced the Bertillon system and kept it going for decades. So there are currently about 400 public crime laboratories. There's federal laboratories, state laboratories, county, city laboratories, and in addition, the military-run laboratories. So the armed forces have a contract DNA laboratory where the U.S. Department of Pathology runs tests. And then there are private forensic science organizations as well. So there's a number of people who are consultants in forensic science and private laboratories that can rerun these tests. So if you think the DNA evidence, you don't want to send your DNA evidence to the laboratory at the state police because you question their objectivity, you're a defendant and you're saying, I don't know if I want to send all that DNA evidence there. I want somebody else to test it too. You can do that. And in fact, they're required to save half the evidence for testing. They aren't allowed to destroy all the evidence in testing. They have to save some for the defense to test it as well. So here in West Virginia, we have a full-service crime lab in Charleston, West Virginia. And for many years, it's been run by the West Virginia State Police. And we still have a lot of people who are in the state police who are working in the crime lab. But increasingly, they've gone to having people not be members of the state police and work in the crime lab. They've gone to having more professional forensic scientists work in the crime lab because of that problem of conflict of interest. And Kentucky has crime labs. The nearest one is in Ashland, and there's a variety of different crime labs in the state of Ohio as well. So there's quite a few in Virginia, and we also have a DNA lab that is responsible for the CODIS work along with the West Virginia State Police. It's like a shared CODIS lab. So that's this DNA database that tests convicted felons and puts their DNA into the database. So if they commit another crime or an unsolved crime is committed and you want to find out if that person's already in the database, you can do that. So they process the samples for the state at our lab, and they do forensic casework. And because there's kind of backlogs of forensic data, they do contract DNA analysis for other states. So they're licensed to do casework and paternity work as well. So there's an increasing number of crime labs because the Supreme Court is making the police more responsible for scientifically evaluated evidence. So there's been a national push for a number of years to use good science. And some of that's because of the higher crime rate and especially the war on drugs. So as more and more people were arrested for drug use and drug use expanded in the United States, we have more drug crime, and then we have more drugs to test. And when we added DNA profiling and DNA testing to crime scene analysis, we had to get specialized people in these crime labs who could do this DNA analysis. And so the government then had to put more money into forensics. So most of the government money for forensics is coming from the National Institute of Justice. And they have a lot of programs for different types of forensic science where they're trying to establish national standards for the quality of forensic science that gets done. So a lot of things they do are create working groups, scientific working groups, and they call those SWGs or SWIGs. So the SWIG groups, there's a SWIG group for DNA, there's a SWIG group for blood spatter, there's a SWIG group for firearms. Almost any type of forensic technology that you can think of, they're putting together a SWIG group. So they would be people who have expertise in the consultants and in the professional crime labs and at universities, and they're going to meet together to write documents that'll be publicly available through the Department of Justice about how police forces should collect this kind of forensic evidence and how this kind of forensic evidence should be examined and used. So that's one of the reasons when you do your paper that I want you to use some of these documents, because there's a lot of free PDFs and quality work that exists for some of these things. So the media and TV shows, one of the problems is they overestimate how fast it is to analyze things. And there is a long forensic science backlog. And that's because there are often samples that are retained that are not analyzed until, for example, if there's a sexual assault, they take a rape kit and then they store the rape kit, and then it goes into a queue until the rape kit is analyzed. And so it can sometimes be 6 months to 2 years until that rape kit gets analyzed. And one of the problems is the offender can offend again and commit another rape. And by the time you get around to analyzing 3 or 4 rape kits from the same offender, and you say, oh, we've got a pattern, we've got a serial rapist, if you'd been analyzing those within a month, you would have seen that you had a pattern from the DNA evidence, and you would have been looking for that person in a different way than you would have a couple years later. You would have been profiling them and looking for them more aggressively as a repeat offender. So there's been a big push from the Department of Justice, and the Bush administration gave quite a bit of money to helping take care of that backlog, and that money has kind of been held up a bit. They aren't putting as much money into solving that backlog as they used to. But once you increase the budget line, even if they decrease it a little bit, it's still bigger than it used to be. So they're still working more aggressively at trying to fix some states' backlogs. Now, historically, West Virginia didn't have a big backlog because we had a forensic science program. We had one of the first DNA labs. And relatively speaking, we're not as big a state, and we don't have as many crimes. So, because rural places sometimes don't have as many crimes as urban areas because we're less concentrated. So that's why our labs can take on additional work and solve some of those backlogs. So in 2009, the backlog was 100,000 cases, and by the end of the year, it was 111,647. And the convicted offender and arrestee sample backlog was almost 1 million. Yes?
Does the backlog of evidence, does it hurt evidence at all?
Actually, DNA evidence is pretty stable. It turns out that the biggest thing about DNA evidence is drying it adequately. If that evidence isn't dried, it can be gone in 3 to 5 days. So, that's why when they find somebody who's a sexual assault victim who has been unidentified for 3 to 5 days, you're kind of past the point where you can use semen or other evidence to tell that that person had been assaulted, because the DNA isn't stable in a moist environment. Sometimes if the evidence is on clothing, though, it can be dried out and be quite stable. So that's one of the reasons people keep dumping the bodies in the water, you know, CSI knowledge aside, you know, DNA isn't very stable when it's wet. But when it's dry, it can go for, I think well, we can get DNA from pharaohs. And, but really we've got a lot of pharaoh relative to a stain at a crime scene. But for stains at crime scenes, probably reliably you can go 20 to 30 years. But it's a bad idea to keep a backlog, because what happens is people lose the kits, they lose the case at work information, the witnesses disappear, the person may change their mind about the prosecution, they may move away, the case looks less urgent. So, and the person who's the victim may be terrorized by the fact that nobody's been apprehended and be personally suffering. So it's actually very bad for society. In fact, for society, one of the best things you could do to prevent crime is catch criminals rapidly and convict them accurately. That is how to solve crime, is catch them and convict them. And so from that perspective, DNA evidence has been very powerful. But if you're not fast enough doing it, it's bad. So I do think it's an important thing to put more funding into that, though. I do think that's a plus. And for us in West Virginia, it's a plus because our forensics labs then are able to pick up additional work from other states. So if they keep funding more backlog testing, it would be beneficial. Now, I should say one of the reasons there's more backlog is probably in this case because they're using DNA testing in more kinds of crimes than they used to. So they used to really limit it to more murders and sexual assaults, and now they're using it in things like burglaries, and they're using it in some fraud cases. The Brinks company is adding unique pieces of DNA to the dyes that they put in the money from bank robberies and robberies, so that if you steal the money from the Brinks bank and there's a little poof that'll spray DNA that's uniquely coded to that list of that particular batch of money that was stolen, like a fingerprint, and they'll be able to uniquely identify that that came from that crime, that money came from that crime. And DNA sticks pretty well, that amount of DNA from those unique pieces. They're not found in nature, so if you're finding those DNA tests in a DNA test, then you're pretty sure it came from the crime. So, and actually there's a company here in West Virginia called Vandalia Research, and they're manufacturing the DNA for that application. So we're pro using DNA to identify the Brinks robberies. Not keen on robbery, but if you're going to have robbery, identify the people. So in the U.S., the first lab that was organized by a police department was the LAPD, and they still have a very large forensic science lab. And the FBI lab was organized in 1932, and they offered specialty services. So even now, if you have a very specialty case, even West Virginia, if we have certain kind of specialty evidence, they send that evidence to the FBI lab. And so if you go on the FBI forensics webpage, you'll find a great deal of information for local law enforcement, about how to ship your evidence to be tested by the FBI. But there is no national system. There's no national hierarchy. Every lab is kind of its own thing, and they're networked and they communicate. There's associations of lab directors. They work on things, but they're not structured like, say, in the military. Or they're more like police departments, where there's state police and there's local police and there's FBI. So just as you have all those different levels of law enforcement, you have all those different levels of crime labs. So in the federal crime labs, it's not just the FBI that is there. There is the Drug Enforcement Administration, and they do a lot of forensics, often to do with identifying specific types of drugs. And the Bureau of Alcohol, Tobacco, and Firearms is also able to do work on forensics. And they often are looking at explosions as well. ATF often is involved in looking at explosions because of gunpowder. And the Postal Inspection Service has their own forensics department. Did anyone know that? They do. They're very interested in fraud, and there's a lot of crime that occurs through the mails, and that the minute you use the mails to commit a crime, you're elevated to being a federal crime. And if they can show that you're committing that fraud with the mails, then the postal people inspect it. And they do DNA analysis. They do all kinds of stuff too. So more places to go get a job. So within the crime lab, there's specialized units in most crime labs, kind of based on the skill sets that the people have in the discipline. So there's a group that are devoted to physical science, so they're doing chemistry, physics, and geology. So physics, people are interested in things like bullet trajectories, and chemistry, they're doing all the drug testing, all the toxicology, plus periodically they're called upon to do other kinds of chemical tests. And geologists, so soil identification. One of the shows I watch all the time, the only forensic show I watch all the time is Bones, and they're always going around and analyzing the dirt. And then they say, based on this soil map, we can take it down to this pier on this boat, and this place. And, there are soil maps. I mean, I've gone to try and figure out, well, is that even remotely possible? And there are indeed soil maps that you can get that connect certain soils to certain areas. But they're not as fine-grained as what they use in the television show. They're not as specific as to this is the neighborhood where this soil is uniquely found. They're more like, oh, it came from the east side of the county. That can be important. East side of the county is more helpful than not, but it's generally not as effective. The other thing they're always doing is they're doing a kind of a mass spec analysis, and they're always like swabbing stuff and then running it through and then saying amazing things they've learned from that. And that's a little futuristic, and I used to think it was pretty much fake, but I've been reading lately that in fact they are improving those techniques to where they can begin to do what they're doing. The trick is you've got to have good standards to compare things with in those tests. So if the standards are there, they can do that for the test. And they have begun to use them for those kinds of swab tests where they do them. So the guy who runs all the chemistry equipment, there's some possibility they can do that. So there's biology units, and they focus on blood and body fluids. And they focus on hair, fiber, kind of things that could be related to bodies. And firearms units tend to be specialized. They investigate firearms, bullets, weapons, cases, cartridge cases, shotgun shells, gunshot residue. So, and really, it's pretty hard to go to school and get a degree in firearms investigation. What usually happens is, and they need firearms examiners. They need those people, and it's a specialty field. So usually what they do is they get somebody who's got a degree in science, and they're less than picky about what science. They like some chemistry, or they like some physics, or they just want a general science degree, and then they get a good, clean background check. And then they send you through and train you, and they send you to extensive national training and local training, and then you get tested and you get to be a certified firearms examiner. So this is one of those fields where you get trained on the job. But you have to have generally they prefer somebody with a science background. So documents groups, again, they look for a general science background, and they give you an apprenticeship and a training. They send you to national training classes. Photographic units exist for going to do crime scene photographs, and these days they're very sophisticated in how they take crime scene photographs. They can actually set up cameras and do, kind of round photographs and create almost like a three-dimensional thing where you can walk in and zoom in on things. And there's companies that sell that equipment to police stations so you can make a very accurate crime scene reconstruction. And there's a big tendency to come in with video recording too. So that way people can be recording what they're doing as they're picking up the evidence. So then, but they still like to take still photographs because it's easier to show those still photographs to the jury. Computer forensics units are specialized as well, and that's because there's so many different types of digital evidence. They have to preserve them correctly so they can be admitted to court. And there's a lot of specialized forensic chemistry units, and they're really focusing on toxicology, blood, alcohol. And there are specialty crime scene investigation units as well. And depending on the field, they may be forensic scientists or they may be police officers. In West Virginia, they tend to be police officers who've had specialized training from the State Police Crime Lab. In LA, they have forensic scientists on the crime scene investigation unit. I think in Las Vegas, which is where the original CSI unit is based on, they actually have more, they have some people who are more involved in the forensics lab coming to collect the evidence. But it's quite variable around the country. Probably there's a goal that more trained people in forensics will do the crime scene investigation, but in a rural dispersed population like West Virginia, that's hard to get to. So you might need to collect that evidence a lot faster than the 7 hours it would take you to drive to Martinsburg. So it makes sense to have somebody local. So some people have latent fingerprint units that can go and collect all the fingerprints, polygraph units. Police departments still like polygraphs. They still like to use them. They use them for their background checks on their own employees. So there's a lot of questions about admitting polygraph evidence into court and how accurate they are and whether people can fake polygraph lie detector tests. But the police still like them. There are people who do voice print analysis, and I think that's going to be even more popular as we get so many cell phones and cell phone messages, although you can tell what phones things came from. So there are forensic psychiatrists, and there are forensic dentists, and as we mentioned, forensic engineers who are going to go out and look at failure analysis, like in our recent failure of the chemical storage tanks. So in the crime lab, people are usually scientists. On the crime scene, they're usually police officers. And Huntington has our own CSI area, and they've got a truck equipped with the stuff they need to go out and collect evidence correctly. And some people have a crime scene rotation where they're working in the lab some of the time, and then they rotate out to collect evidence in the field. So if you're LA and you have a lot of crime and you're in a big city, that's one thing that they do. Whereas if you're in a rural area, you're kind of like us. So what are we looking for? Are any of you interested in becoming forensic scientists or CSI type people? So in fact, it is considered to be a field where there is job growth, because as we expand our knowledge of forensics, there are going to be more jobs for scientists working in this field. So what they're looking for is no criminal record. Now, does that mean you've never smoked marijuana once? Or, or had a speeding ticket? Actually, if you go read the requirements to be in the FBI, they have some small amount of, casual experimental drug use they'll overlook. But they're not looking for a record of doing that. And they will give you a lie detector test. They're looking for you to be a really ethical person. So when I write a letter of recommendation for somebody to go into forensics, I always refer to how well I know them and how honest and I think they are as a person. So I'm always trying to emphasize that because that's a key thing they're looking for. They want you to be pretty self-confident and able to speak in public because you might have to testify before juries. They want you to be able to think scientifically and explain it to lay people. And they want you to have good report writing skills. So that's why the writing intensive aspect of the class is not completely worthless. You know, writing reports and documenting everything you see. To be honest, they also are looking for people who are friendly and pleasant, because you're working in a lab with people. If they're irritating, it really grinds you down. You want people who are really kind of meticulous, and so they mention good hygiene, but part of what they're looking for is also people who are just really persnickety and careful. If you have a little bit of obsessive compulsive disorder, not too much, but a little bit, it's actually in the good side. You know, if you're just a little bit on the over careful side, this is a characteristic that does well in forensic science, because they got to be like I dotters, T crossers. They should avoid taking unnecessary risks. They should be kind of conservative in their science. Well, we collected that sample, let's collect another one. You know, let's have two. You know, let's test it again. So they tend to be careful. They're good at managing their time. They're good at multitasking and organizing, and they work well, and they're patient, because it can be years until forensic science evidence actually gets presented in court. Now, I actually think that's a flaw of our legal system, that we really need to put more money into getting this to court faster. I think that would make everything work better. That's my policy statement for the day. But in fact, it is what it is. So if you're really, really frustrated by it, you're not going to make a good forensic scientist. So, and they have to be able to do things in a careful, rigid way, but also think outside the box, because they're always being presented with cases with evidence they've never seen before and novel things. So they have to be able to take what they know about science and apply it to a new situation, and be able to justify how they applied it to that new situation. So they need to be able to train law enforcement, so they need to be able to work well with all kinds of people. They have to be able to recognize the evidence, collect it, and preserve it. And as I said, they have to be able to go to court. So in court, they have to be able to explain things to laypersons who are sitting on the jury, and who we've already discussed are likely to be less sophisticated people. So they're going to have to explain how the scientific method works on this. They're going to have to be able to take complex science and make it simpler. I've worked a lot with a guy named Ted Smith, who was the former head of the state police, and in fact he used to teach this class, and he was great at explaining things in a simple way for the jury to understand. He could make things very clear to laymen. So just throwing a bunch of vocabulary around and trying to intimidate the jury is not going to work, because you want to be able to explain it so they can understand it. Now, we'll talk a little bit more about how evidence gets admitted, but there's several important Supreme Court cases that govern what kind of evidence can be admitted into court and how a forensic scientist can testify about that evidence. And part of what's required is that the scientist must have consensus about the forensic science evidence that's presented into court. So if you've got something that's very strange and weird, and you have to be able to explain why that's an acceptable forensic science method to the jury, or the judge won't let it be admitted. So for every new forensic science technique, they have to have what they call a Daubert hearing, where they talk about, is this really an acceptable scientific method? So there was the Casey Anthony trial. Did any of you follow that? It was this young woman in Florida who had a 3-year-old daughter, and the 3-year-old daughter disappears, and the hard partying mom doesn't bother to report that for a couple months, and then finally she says, oh yeah, the babysitter kidnapped her, and then it turns out the babysitter never saw this kid and never kidnapped the kid, and then next thing you know, they start looking for the body, they can't find the body, and eventually somebody goes to her parents' house and looks in the swampy back area near the house, And he's like some guy who's just like interested in the case. And he's going out looking for the body. And so he goes out and he locates the body in a plastic bag. And so naturally he winds up contaminating the crime scene somewhat. But they bring in all these people to testify about the smell of chloroform and whether or not her car smelled like chloroform and whether or not her car smelled like decay. So, and whether or not they could go back to her trunk and detect whether or not chloroform or decay had been in her trunk. And so they've got these kind of tests that they're using, and they become key parts of the evidence, and then they bring in expert witnesses to argue against the validity of those tests. And so the jury winds up unable to figure out if those tests are valid or not, and that's part of the reason why they don't convict her of murdering her child. Plus the fact that it's skeletal evidence many months later, and it's hard to, her story was, well, the kid died, so I just got rid of the body. And then somehow didn't mention it anyway. So I think most people suspect she committed this crime. I mean, if you ask most people, they would say, yeah, it seems pretty likely. But the jury is called to sit in isolation and really decide beyond a shadow of a doubt. And frankly, some of my colleagues have said they don't think that evidence was very solid. The evidence on the searching for chloroform on the internet was probably better evidence. But they didn't present that evidence very well. So that evidence from the computers was probably better evidence linking her to the crime. But her mother kind of covered up for her in that respect. So getting the evidence admitted and getting it understood is a tough thing. So we'll pick up here on Friday, and hopefully by Friday I'll have figured out how to record things. So I'm going to end show and then see how my recording is going on. Pause and stop.